Okay, good morning, everybody. I hope you guys are doing well. I have a very quick lecture for you. There's only two examples here, and this is just utilizing the log properties that I explained a couple days ago to just kind of really just manipulate expressions. It's not really making them any easier to express other than just using the log properties for the sake of the log properties and just practice using them. So let's get started. I'm going to show you how to rewrite a couple of logarithmic expressions. So it says the properties of logarithms are useful for rewriting logarithmic expressions in forms that simplify the operation of algebra. This is true because these properties convert complicated products, quotients, and exponential forms into simpler sums, differences, and products, respectively. So I'm going to show you how to take a log expression and expand it using those log properties. Now, you can also, and will be asked to do the exact opposite. I'm going to eventually give you log expressions where you'll have to condense them down into a more compact expression as well. And those, again, are just using those log properties. So let's try this first one. It says log base 4 of 5 times x to the third times y. The first thing to notice here is this is a log of a product. And there are three things in this product. We have a 5, and we have an x to the third, and we have a y. So that, scrolling back to a property that we had something called the product property. And what the product property allows us to do is to expand that product and log each of the pieces of the product individually and put a plus sign in between each of the logs. So that's exactly what we're going to do. We're going to take this expression that's right here, log base 4 of 5 x to the third y, and we're going to log each piece individually. So we're going to have log base 4 of 5 plus log base 4 of x to the third plus log base 4 of y. One thing to note, because we started with log base 4, each of the logs, when it's expanded within the product property, will also be log base 4. Now, there is one more step to this, and that is to look at the center part of the product where you have log base 4 of x to the third. It is x to the third. It has a power on the thing that is being logged. When there's a power on whatever's being logged, the power property allows us to bring that exponent down and put it in front of the log. And so that's what we're going to do. So the final answer to this expansion is log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. All right, now moving on to part B, you can see that we have natural log, which is just log base e, of the square root of 3x minus 5 over 7. So this is a fairly complicated expression in that we have a little bit of cleanup work that we need to do before we can actually utilize the log properties. The first thing to do is to rewrite this square root as a power. This is really important when you're dealing with logs. If you have any sort of root, you need to rewrite the root as an exponent. So if you have square root, it's 1/2 power. If you have cube root, it's the 1/3 power, and so on. So you can see that we rewrote this so it's 3x minus 5 in parentheses, which is necessary, to the 1/2 power. The next thing to notice is that this is an expression that is dividing. So therefore, if I scroll back to those properties that we learned last time, you can use the quotient property, which is specifically for this scenario. When you're logging a quotient, you can divide it up and write the log of the numerator minus the log of the denominator. So that's exactly what we're going to do in this expression right here. We're going to take the numerator and we're going to, I'm not sure what happened to my slide here. This starts out as natural log of the square root, and that turns into, I must have deleted it. There it is. That turns into the 1/2 power, and then we're going to break this up so it is the natural log of 3x minus 5 to the 1/2 power minus the natural log of 7. So it's the natural log of the numerator minus the natural log of the denominator. From there, we're going to utilize the power property. Again, we're going to bring this 1/2 back down and in front of only the first natural log. The reason why it only goes in front of the first natural log is if you look in the original expression, only the numerator was being square rooted. Therefore, only the numerator log needs to have the 1/2 in front of it. And that's it. So there is an expansion of a logarithmic expression using your log properties. All right, guys, I'd like you to try 38 through 58 even. As always, if you have any questions, feel free to email me. I hope you're all doing well. Take care.